Hello 108 students, Mr. McHugh back here with you on 7.1. We are going to wrap up the last page of this section on page 4, and we're basically going to deal with how do you divide rational expressions here. And Objective 5 talks about reciprocals, and it just wants us to remember the basic idea from fractions, such as if I had 2/3, if I multiply by the reciprocal, and that basically means you switch the numerator and denominator, so the denominator goes down, the numerator goes up. I'm sure everybody remembers that. And what's the amazing thing when you multiply any fraction times its reciprocal? That's right, it always equals 1. The same concept happens with rational expressions. Okay, here's just a quick example. Take a rational expression and multiply by its reciprocal, flip the numerator denominator, bring it down, bring it up, and what you've got here is m squared minus m. That is on both the numerator and denominator, top bottom. It cancels out, the 2 and the 2 cancels out, and you're equal to 1. Okay, so with that said, when you deal with objective number 6, it's going to have you do problems where you're going to have the division of rational expressions. Okay, and just like fractions, you're going to convert them into multiplication, and hopefully you remember these. Okay, you multiply the first rational expression by the reciprocal of the second rational expression, and it's just the same idea with regular fractions. Okay, same technique. Okay, so with that said, here's an example 5a that's going to allow us to see how this works. So here's 2z divided by 9. That's a rational expression divided by 5z squared divided by 18. Okay, now first thing, leave the first rational expression alone. Second, take the division and convert it into, multiplication. Multiply by the reciprocal of the second rational expression. So 5z squared goes from the top to the bottom, and the denominator goes from the bottom up to the top. Okay, so I flipped them. Whatever you want to say, that's the reciprocal. Okay, now what do you have when you do that? Now, I see 18 divided by 9, and that's a 2. And I have 2z squared left over 5z squared, and z over z cancel out, leaving you a z. Excuse me, I did that wrong. I did it over here, sorry. Z divided by z squared is equal to 1 over z. Okay, so I think I've done this before, but there's 1 divided by z left over. Okay, so I got up here, then you've got the 2, 18 divided by 9 is 2, 2 times 2 is 4, 5 times z is 5z, and you're on your way. Okay. Good thing about dividing rational expressions, except for to kick it off by multiplying by the reciprocal of the second rational expression, the rest of it you're going to go ahead and factor and then simplify. So let's take an example here of 5c, and 8k minus 16 divided by 3k. Okay, here's the division. Convert it into multiplication. There's the reciprocal going down. Okay, so here's where you really start the problem. Okay, now what did you do back in the last section? Every time you see, if you could want to put parentheses around these, that helps you, go for it. Okay, now can you factor? That's the key thing. Factor, factor, factor. You betcha. I could pull out an 8 for the GCF. I'm left with k minus 2. 4k squared, leave it alone. Down here, 3k, you leave it alone. And then look at 3k minus 6. Can you factor? The answer is yes. There's the GCF, and you're left with k minus 2. Okay, you do all that work, and you step back for a second, you say, do I have any factors stacked on top of each other? And the answer is yes. I see k minus 2, parentheses, a k minus 2, so they are equivalent to 1. And I'm left with 8 times 4 is 32, 3 times 3 is 9. I'm left with k squared, and I'm left with k. Is everybody comfortable how I got that? Okay, now from here, you're left with what? K squared divided by k is simply k. How did I do that? Divide by the same base, subtract the exponent. Is 2 minus 1 is k, or if you wanted to, this is kind of awkward, but you can cross them out that way. You're left with the k. Okay, and in fact I said that over here, didn't I? Sorry. Okay, so now you're left with your final answer of 32/9. Can you simplify that? No, nothing goes into them evenly. If it would have been 33/9, it would have been a different story, but it's not. Okay, there you go, folks. Class, that's it. We have finished up section 7.1. We are going to move on to section 7.2. We're going to add and subtract rational expressions. So that'll be our next task. So Mr. McHugh checking off here, signing off for section 7.1, and I'll see you on the next video. Okay, take care. Bye.